Hello everyone, welcome to this new discussion. Feel free to click on the subscription button below to subscribe to my channel. Click also on the bell below to get a notification of all the discussion I will be releasing, and feel free to share the video with others.
ABS, or the anti-lock braking system, has been a key component of our vehicles for many years. There are lots of DTCs that can set for this system. In this module, we'll look at the wheel speed sensor codes. Each of these DTCs relates to a particular wheel speed sensor. C0035 is for the left front wheel speed sensor, 0040 for the right front, 0045 for the left rear, and 0050 for the right rear. The diagnosis of these sensors is the same, only the wires to the ABS module will be different. Here is a typical schematic for the wheel speed sensor circuits. Each wheel speed sensor has a 12-volt reference and goes to a pull-down circuit. This may vary on different vehicles. The wheel speed sensor receives ignition voltage from the module and provides an output signal in the form of a square wave back to the module as the wheel spins. The module uses the frequency of this square wave to calculate the wheel speed. From the fault table, it can be seen that these DTCs can be caused by a short to ground or an open/high resistance on either the signal or 12-volt reference circuit, or a short to voltage on the signal circuit. If two or more wheel speed sensors are inoperative, diagnose each sensor individually. If the customer comments that the ABS indicator is on only during moist environmental conditions, such as rain, snow, vehicle wash, etc., inspect the wheel speed sensor wiring for signs of water intrusion. If the DTC is not current, clear all the DTCs and simulate the effects of water intrusion. Observe the scan tool wheel speed sensor parameters while driving in a straight line at greater than 40 kilometers an hour or 25 miles an hour. The readings should be the same on all sensors. Inspect all the tyres for correct air pressure and the correct size. If they are not all the same pressure, adjust the pressures to specifications. If not all the same size, replace the incorrect tyre. If any of these faults were found, then clear the codes, road test the vehicle, and verify that the DTC doesn't reset. If the tyres and pressures are all right, or the code returns, then you'll have to perform the following diagnosis. Always start electrical tests by measuring the battery voltage. Most of these tests are conducted with the ignition on. Always turn the ignition off before connecting or disconnecting sensors or modules. Disconnect the appropriate wheel speed sensor. Connect the multimeter between the 12-volt reference terminal of the harness connector and battery negative. You should see approximately 12 volts. If the voltage is low, then this will indicate that there is a resistance in the wiring, faulty connectors, or a possible module fault. If there's a harness connector in the circuit, you can test again at this point. If the voltage is now correct, then the resistance will be between the harness connector and the sensor connector. If the voltage is still low, proceed to the next connector in the circuit and retest. Back probing the module will be the last place to check the wiring. If the reading is still low, then the fault will be either the module connector or the module itself. The connector can be checked for corrosion and terminal tension, and if this is okay, then the module will be the cause. If there's no voltage at the sensor connector, then it will be necessary to check for a short to ground or an open circuit on the 12-volt reference circuit. To check for a short to ground, move the multimeter lead from the negative terminal to the positive terminal of the battery. A voltage indication here will confirm a short to ground. Disconnect the module and retest. If the voltage is still there, then the short to ground will be in the wiring harness. If the voltage is now gone, then the fault will be in either the module or a ground from the module shorted to the signal wire. To test for a shorted signal wire, connect one probe of the multimeter to the sensor connector 12-volt reference terminal and see if there is a connection to any other terminal in the module connector. If there is no short to ground, you'll need to check for an open circuit. Back probe the module to check for the 12-volt reference. If there is no voltage here, then it must be a faulty connector or a faulty module. Check for terminal tension of the connector. If there is no short to ground or no open circuit, then the module will be at fault. If the 12-volt reference circuit is okay, then the signal wire will need to be checked. There should be a ground on this wire from the pull-down resistor. To test this, connect the multimeter between the sensor connector signal terminal and battery positive. You should see close to battery voltage. This will indicate a ground on this circuit. To determine if it's a ground from the module or a short to ground, simply unplug the module and retest. If the voltage reading is still there, the ground must be coming from the wiring harness. If the reading is now gone, this means that the wiring is testing okay. So it'll be necessary to test the sensor. To test the sensor, you'll need a graphing scan tool or an oscilloscope. If using an oscilloscope, it will be necessary to backprobe the module or the sensor to get a pattern. Again, turn the wheel at a constant speed while observing the pattern. You should see a steady square wave. If these tests reveal a good pattern, then the fault would have to be the module. Wheel speed sensor faults. Follow the procedure. Work on one part of the circuit at a time. Diagnose, don't guess. And remember, training is the key to your success. Bye for now.
Feel free to click on the subscription button below to subscribe to my channel. Click also on the bell below to get a notification of all the discussion I will be releasing, and feel free to share the video with others.